Alright, so in today's video, we're going to be covering area of regular polygons. So it's a continuation of the other videos. But what's different is we are going to be seeing some special right triangles inside these regular polygons. And so before we start, we need to refresh ourselves on special right triangles that we've seen in the past. So one of those being 45, 45, 90 triangles, and then the other would be 30, 60, 90 triangles. And so let's put out a visual so we kind of refresh ourselves on the ratio for each of those. So I'll go ahead and draw a right triangle to represent our 45, 45. And so we have our 90-degree angle, 45 degrees in this angle, and 45 degrees right here. And reminding ourselves that the ratio for this is, I guess for both of these legs here, can represent that as x, or a 1-to-1 ratio. And then for our hypotenuse is going to be that short leg times root 2. And I'll just label that as the height. So that's that ratio there. And if you also want to, actually no, let's go ahead and jump into the 30, 60, 90. So let's go ahead and draw another right triangle there. But as we remember, the interior angles will look a little bit different. We do still have our right angle. We have one at 30 degrees. We have one at 60 degrees. And so across from the 30 degrees, we call this the short leg. And that's going to have a value of 1 or x. Then across the 60 degrees is going to be our long leg. Not longest leg, right? That's our hypotenuse. Our long leg, and that's going to have a value of x times root 3. And then finally across the hypotenuse, or across the right angle, which is our hypotenuse. So it's our hyp side. That's going to be 2 times the x value. And so those are the ratios there. And I'll say with finding area of regular polygons and seeing special right triangles, the most common special right triangle you'll see is not this one. This one's more common in squares, but the ones you will see a lot of are 30, 60, 90 triangles. And the types of regular polygons that you'll see these show up in are going to be triangles. You're also going to see it in hexagons. And so I'd say those are the two common ones in which you'll see them. So let's actually go ahead and jump into an example of this. So I'm going to go and head over here. Here's a example of some problems that involve special right triangles. And like I mentioned already, the most two common shapes you'll see are going to be hexagons, or you're going to see triangles. So let's see, what problem can we start with? Why don't we start with a triangle. So I'll zoom in on this problem here. The first thing you should be doing is obviously recognizing it's a triangle, recognizing how many sides do exist here. So we have 3 sides. And the next thing I would do is draw your center point right there, connect those to your vertices so you can draw your mini triangles. All right, there are your 3 triangles. Next thing is drawing your apothem. So I'm going to go ahead and draw mine right here. All right. And then this is where we start focusing on our little mini right triangles. And so what I'm going to do at this point is I'm also going to find out what this central angle right here is for this entire mini triangle. And remember, to find a central angle, all you have to do is take 360 and divide it by the number of sides. So in this case, that would be 360 divided by 3. So the value of this entire central angle right there is 120 degrees. But because I'm trying to focus on just one right triangle, I want half of that, right? This is a half central angle. So you could use either this little mini right triangle or this one, but we're gonna take 120 and divide that by 2, and that's gonna give us 60. And so already, right, I'm writing 60 there. You know this is 90, that's gonna leave this as 30. So like I mentioned, this is gonna involve a 30, 60, 90 triangle. So why don't we go ahead and take this mini right triangle here, and I'm gonna draw it on the outside. It's a little bit easier to visualize that way. So I'm gonna keep the way that it's rotated. All right, so we have a 90-degree angle there. This here we found out was 60 degrees from it's a half central angle. And that would only leave for this angle right here to have a value of 30. All right, cool. And so what we don't know so far, right, we don't know the value of I'm just gonna call it the apothem right here, right, AKA our height of our triangle. And then we were given a base of 10 root 3, but because we've split into this right triangle, we need to take this entire base here, or side length, and we need to split it in half. And so I'm going to take this and show that work over here, because that's going to represent the value of this leg right here. And actually, before I do that, let me go ahead and remind myself that across the 30 degrees, so this is going to be my short, across the 60 is going to be my long leg, and then this is going to be my height. All right, my bad. So I'm going to take this and I'm going to divide that by 2 to half it. And so we have 10 root 3, and I'm going to have to divide that by 2. And so this will easily just simplify to 5 root 3. All right, so now that I have this info, I'm going to plug it in back on the side over here. So let's use a different color. Let's go ahead and say this is 5 root 3. And if it helps, right, I could rotate this a bit. So let me actually do that. Sometimes seeing these triangles upright makes it a little bit easier to understand and recognize how we normally look at it. So I've rotated that. Let me actually redraw these in. So this was 30 degrees, this was 60 degrees. This had a value of 5 root 3. Right, I have no idea what the short leg value is, and I'll rewrite these. So long leg, and we have our short leg. And so overall our question is find an area, right? So in order to find area, we need base, we need height. So far we just have height, but because we know this is a 30, 60, 90, I can use the ratio from earlier. So I know that the value here has a value of 1, this has a value of 1 times root 3, and this has a value of my short leg times 2. And so I always recommend to take whatever given information and find the short leg first. So going from long leg to the short leg, what you have to do is you just divide by root 3. And so we have this value of 5 root 3. We're going to divide that by root 3. I'm going to go ahead and show that over here. So 5 root 3 divided by root 3. This is to get the short leg over here. And so what's nice here is we have the same values on the top and the bottom. So that's actually just going to cross out and leave us with 5. And so that value there is 5. I'm going to go ahead and erase some of this work. It's in the way. Get rid of this as well. All right, cool. So now we're getting somewhere. we have a right triangle, we have the value of our height, we also have the value of the base. So from here, you can go ahead and just follow area normally and use these two values. And so it's going to be base times height. So that's 5 times 5 root 3, all divided by 2. So that's going to leave us at 25 root 3 over 2. Okay, and then we're going to go ahead and leave this as the area just for that mini right triangle. And remember, because we only found the value of half of one of our mini triangles, what we can do is take this area and not multiply it by 3 triangles, but double that, because we have to imagine that all of these are also cut into mini right triangles. So double of the 3 is going to be 6. So we're going to multiply that all by 6. And I'll go ahead and draw that over here. So 25 root 3 over 2. 25 root 3 over 2. And we're going to multiply that all by 6. And so now we have 150 root 3 over 2. And then what's nice is that this can simplify. 150 can get divided by 2 and leave us with 75 while still keeping our root 3. And so this would be the total area of the regular triangle, right? So we just found the entire area of this right here. And so you can pause the video here and you can try some problems on your own, but I'm going to go ahead and do one more, but this time it's going to be involving not a triangle, but we can go ahead and look at one of these hexagons. And so let me find a hexagon problem. We can do, let me go ahead and do this one right here. All right, same process. Recognize it's a hexagon. 6 sides. First thing you do is draw out your mini triangle. Actually, I'm going to do it at the bottom here. It's easier to recognize. And then I'm also going to draw my mini height, aka my apothem. And because I know this has a value of 6 root 3, I'm going to also write it at the bottom base of my mini triangle. So this whole thing down here is 6 root 3. I know this gets cut into a mini triangle. And so next thing to find is my central angle. So I can actually find my half central angle for this mini right triangle. And so 360 divided by 6 gives us a value of 60. And that's just this central angle right here. So this has a value of 60. I'm going to split that in 2 to get the half central angle. And that's going to give me a value of 30. And so from here, I would suggest you draw out your mini right triangle off to the side. So let's do that. All right, there's our right angle. Here's our 30 degrees. And this would make this 60 degrees. And so also we need to recognize that this whole value of this base is not 6 root 3, but it's actually half of it. So that means I have to take this and divide it by 2, which would give me a value of 3 root 3. All right, all I did was take this entire base and divide it by 2. So I can get this value over here. Cool. So now we can get to work. What we are missing is our height again, or our apothem. So then we can continue finding our area. And so we know the value across 30. Actually, let me just call this the height because it's missing. And so across the 30 degrees, the ratio there is x. Across the 60 degrees, so our longer leg is always going to represent x times root 3. And so if we're going to go from short leg to this longer leg, all I need to do is take this value and multiply it by root 3. So that means I'm going to take all of 3 root 3 times another root 3. And so I'm going to go ahead and do that down here. So 3 root 3 times root 3. that's going to give us 3 root 9. And then notice that this can be square rooted. And so I'm going to bring down 3. I'm going to bring down the multiplication sign, and this becomes also 3. And we know 3 times 3 gives us 9. And so what we just found, again, is our height, or apothem. And so I can go ahead and erase the height here and replace that with what we found, which is to be 9. Going to go ahead and erase this work here, and now I can move forward with my area. So base times height divided by 2, just to get that little half, that little right triangle right there. So 3 times 9 divided by 2, and that's going to give us 27 root 3 over 2. And then 27 doesn't divide nicely into 2, so I'm going to leave this area of the right triangle as that. So we just found this area, and instead of multiplying this area right here by a total of 6 triangles, this is just half, so I must double the amount that I am doing that by. Man, I drew that a little bit bad, but we basically double it up. So instead of multiplying by 6, we're going to double that, and we're going to take this entire value and multiply it by 12 sides instead of 6. And so I'll do that right over here. 27 root 3 over 2. We're going to multiply that by 12 instead. And so 27 times 12 gives us 324, keeping that root 3 all over 2. And then these divide nicely. So our final total area of the hexagon, that regular polygon there, is going to be 162 root 3. So leaving it in radical form. All right, and that's it. And so what you've seen now is an example of us using special right triangle knowledge to find the area of this regular polygon that's a triangle, and then also one with a hexagon. All right, I hope that